Okay, this is one of the question based on the stoichiometric calculation. Calculate the amount of water produced by 32 gram of methane uh, on combustion. On combustion. Do you know the meaning of combustion? Combustion means burning with oxygen. So here methane you have to burn with oxygen. When methane is burnt with oxygen, it produces water and carbon dioxide. You should know about the reaction. So how much amount of water will produce, that you have to find out. So this is one example of your stoichiometric calculation. So before doing it, first time you have to write the reaction. So your reactant is methane. When methane is burnt with oxygen, I mean when methane undergo combustion, then it produces carbon dioxide and water. Any hydrocarbon when burnt with oxygen, it always produces carbon dioxide gas and water. So this is your reaction. Now the reaction is balanced or not. I think reaction is not balanced. Here 4 hydrogen, here 2 hydrogen, that's why you have to put 2 here. So now the oxygen, here 2 oxygen, here 2 oxygen, 4 oxygen, so you put 2 here. I think now the reaction is balanced. Carbon balance, oxygen balance, hydrogen balance. So first time you balance the equation. So here you have seen the amount of methane, it is 1 mole according to reaction after balancing. Amount of water 2 mole. I have not written the carbon dioxide mole and oxygen mole because the question is given the relation between methane and water only. So that's why methane 1 mole, water 2 moles. Now 1 mole methane means carbon mass is 12, 4 hydrogen 4, 12 plus 4 you will get 16 gram. This is the molar mass of methane, 1 mole. Water molar mass is H2O, 2 plus 16, 18, 18 into 2, 36 gram. 2 moles water means 36 gram. Now I will do the calculation. Here you have seen 16 gram methane can produce 36 gram of water. Therefore, you according to question 32 gram, na? So 32 gram of methane can produce 36 divided by 16 into 32. I mean you will get 72 gram of water. So like this way you can find out how much amount of water will produce when 32 gram of methane reacts. So this is one of the stoichiometric calculation. Like this way you can find out. Another question, calculate the mass of iron. Calculate the mass of iron which will be converted into its oxide by the action of 18 gram of steam. Steam means water vapor. 18 gram of steam on it. So this is your question. Calculate the mass of iron which will be converted into its oxide by the action of 18 gram of steam, water vapor, on it. So how to do it? First time, here also you have to write the equation. Iron, when it is combined with steam, water vapor, then it will convert it to its oxide. Iron oxide is Fe2O3 and it will release hydrogen gas. So first time you have to balance the equation. Here 2 Fe, so you put 2 here. To balance oxygen, 3 oxygen, so you put 3 here, you put 3 here, then the equation becomes balance. Now steam, here amount of water is 3 moles. 1 mole means 18 gram, 3 moles means 18 into 3, 54 gram. So 54 gram of water is present, and mass of iron is 56 gram. I mean here 2 moles iron, 2 moles means 2 into 56, I mean you will get 112 gram. 112 gram. So that means you can write now 54 gram steam, I mean 54 gram water vapor reacts with how much gram of iron? 112 gram of iron. 112 gram of iron. Now the question asks, if 18 gram of steam is present, how much iron is required? So therefore 18 gram steam reacts with, then the iron required 112 divided by 54 into 18, this much gram of iron. 18 3s are 54. This will not cancel. 112. So we will get 37.33 gram of iron. So like this way you can find out the amount of iron when 18 gram of steam is present. Actually in your reaction 54 gram of steam is present, but instead of 54, if 18 gram of steam is present, then how much gram of iron will react, that you can find out like this way. And that is called a stoichiometric calculation from a chemical reaction. Thank you.